Thank you, everybody, for joining our RV.NUG meetup today. We are very excited to have all of you with us. We continue to have our online meetups, and we plan to add physical presence meetups starting next year. Looking really forward to that. As always, we continue to bring our group together and bring you great speakers and content. And today is no exception. We have a fantastic presentation lined up for you by Steve Michelotti on C#10 new language features. Steve Michelotti is a principal software engineer for Microsoft on Azure engineering team, focusing on building systems to enable government missions. He is a contributing author for Pluralsight Training and a member of ASP Insiders. Before joining Microsoft, he was a 7-time Microsoft MVP in ASP.NET. In addition, Steve is a frequent presenter at developer conferences and user groups like ours around the world, including Microsoft Ignite, MS Tech Summit, VS Live, and Angular Mix. Steve also hosts the Azure Government Video Series on YouTube, so check that out. Before Microsoft, he served as an architect / developer for Applied Information Sciences, that's AIS, where he led numerous projects, including multi-year effort to modernize the business systems of a major insurance carrier. Previously, he was the Chief Technologist at e.magination, that's e.magination, where he consulted with clients, including advertising.com and AOL, where he was the tech lead for one of the highest volume .NET applications in the world. It's a pleasure to have you here with us. Steve, take it away.
Oh, thanks. I'm not used to getting the full readout of the bio there. I had to remember some of that stuff. So happy to be.
It's an impressive bio, by the way.
But it also makes me feel a little old. I've been at this for a long time. I have a son now who's a junior in college in computer science, so it's all coming full circle. Happy to be with everyone here tonight. As mentioned, we're going to be talking about C#10. At Microsoft, I'm on one of the Azure engineering teams, so I'm not on the C# team. But it's nice because we can reach out to the different teams when questions arise and whatnot. And certainly our teams are using C# primarily in our applications as the systems we build. Okay, so what I'd like to do, anytime I give any type of C# talk, and it's funny because a couple months from now, we'll be doing this talk C#11, because that'll be coming out very soon. But I'd like to start with a little bit of a history lesson, because I think it's important to have that context of where we've been to understand where we are now and where we're going. And so when I think about, I just made the comment about feeling old. Well, I've been doing C# since C#1, which came out in 2002, let's say, and that corresponded with .NET Framework 1.0 and 1.1. And right out of the gate, C# was a very full-featured, object-oriented language that had support for inheritance and interfaces and really robust language out of the gate in terms of a 1.0 version of a language. But then in 2005, we had C#2 that was released, and this corresponded with .NET Framework 2. And there was a ton of new features that came out actually in C#2. And these were things like static classes and iterators and anonymous delegates and things like that. But without a doubt, the headliner feature of C#2 was generics. And generics allowed us to avoid a lot of the unboxing and boxing that would happen with value types previously in the versions and things like that. And then .NET Framework 3 was released, but that was not a new rev of the language. When .NET Framework 3.5 came out in 2007, this did have a new rev of the language. This was C#3. And once again, a slew of new features came out with C#3. And these are things like lambdas and extension methods and anonymous types, type inference with the var keyword. But once again, despite all these features that came out, there was one kind of big headlining feature that got all the press, so to speak, and that was a link. And in fact, a lot of the features I just named were there. They were good features on their own, but they combine together in a very elegant way to really give Link a lot of the power that we use. And then C#4 came out in 2010, and this corresponded to .NET Framework 4. And not as many number of features that came out. These were things like named and optional parameters, some enhancements with covariance and contravariance, and some enhancements with COM. Once again, this had a headlining feature, kind of the one that got all the attention, and this was dynamic. We had the dynamic keyword, and the running joke was this allowed us to statically type things as dynamic. But it allowed, at that point in 2010, a lot of dynamic languages, not just JavaScript, but Ruby and things like that, were adding more of those features to the language. Fast forward a couple years, 2010, we have C#5, 4.0. This really comes down to one thing, and that is async and await. And that had a really transformative effect on the industry, I think. Even when you look at the async and await features that were added to TypeScript and even regular JavaScript, the ECMAScript standard, that came from this early work in C#5. And then something interesting started happening in C#6 in 2015 that corresponded to .NET Framework 4.6, which was there was no big headlining feature. There was a bunch of new features added. These were things like string interpolation and auto property initializers and expression body members and things like that. I guess if there was one feature that probably got talked about more than any others, it was Roslyn, which was like the compiler in the box, although that wasn't necessarily something you would use in your everyday work at runtime. But the fact that C#6 did not have one of those big headlining features like generics, like link, indicated a couple things. One of which was C# was becoming a pretty mature language by that point. And a lot of the features that were being added were more things that were, things that you would want to work, but just maybe they didn't work before and now they would just work. And you see a lot more of that theme as we start to go forward. Or little things that are just like, oh, this isn't life-changing, but just sure is nice. I sure will use this, and it's going to be a nice convenience, even if it's just little syntax sugar changes. And so you start to see this pattern go a little bit more. So in C#7 in 2017, that was also noteworthy because now we had .NET Core, and you start to get in a world where this language isn't directly tied to the framework as it may have been in earlier versions. And so with C#7, we had things like tuples and deconstructors, not to be confused with destructors, and local functions, pattern matching, out variables, digit separators, little nice to have to make it easier to read code. And then another interesting thing happened later in 2017, and even in the beginning of 2018, is we had point releases of C# for the first time. You had C# 7.1 and 7.2 and 7.3. And again, it was interesting because if you weren't paying very close attention, you may not have even noticed them. Because in earlier versions of C#, when a new version would come out, there was all this fanfare, and these were really released kind of quietly. And there were some nice features that came in there, like async main. We had to always do weird things in console apps to do asynchronous code in the main functions. Little nice to have like inferred tuple names, private protected, you thought would have always been there, was never there before. Little tweaks, nothing that was, amazing. Just again, some nice to haves. Like I said, if you weren't paying close attention, you may not have even noticed. C#8 in 2019, .NET Core 3, 3.1. You had more pattern matching. You had some interesting features with indexes and ranges, static local functions. I guess maybe if there was one core feature that was nullable reference types, that was probably the most interesting feature added in that one. And then now we're getting to 2020, before COVID, C#9, .NET Framework 5. I would definitely say that the feature that got all the attention here was records, and we'll certainly talk about records more tonight. But there was also some interesting things with target type new expressions, more pattern matching enhancements, things like that. And you'll actually kind of see me use some of those features as I go tonight, as I'm introducing some of the things with C#10. And the difference is what the code might look like prior to C#10 and with C#10. But what you're going to see with C#10 is there's not one feature where I'm like, this is it, guys. This is the feature that is the feature to end all features. C#10 is very consistent with the features you've been, the releases in the last few years of, I'm going to show you a bunch of features that are nice to haves. They're going to help you write more concise, succinct code. There's going to be a couple features I'm going to show you that you're going to be scratching your head and saying, wait, that didn't work before C#10, because some of the features are things that would confound people when they would get compiler errors. Why isn't this working? This should work. And they probably had a good point. Maybe they were just things that the C# team didn't have time to get to in early releases. So you may have find instances where you're like, why doesn't this work? This should work. And in C#10, they just kind of start to work. So they're just kind of nice to haves, and I'll point them out as we go. So with C#10, we're going to cover these 12, I guess, features. And there's also some other features that came with C#10 that I'm not going to cover because I didn't think they were demo worthy. So we're going to cover a lot of information, and that's it for PowerPoint. Let's jump right into the code. So from here on out, we're just going to be in Visual Studio. So I'm using Visual Studio 2020, and I'm just going to create a new project, and we're going to create a console app, and I'm simply going to name it C#10 demo, and I'm going to put it in my dev folder. And notice that I'm making this C#6 long-term support right here. And so we're using the latest and greatest version of the framework, and we'll go ahead and let Visual Studio create this file new project here. So this actually doesn't necessarily look different. We had this in earlier versions where it's just the main method. You don't see some of the namespaces and everything that came. This was actually the case in previous versions of .NET. So if we see this, you'll see that I can just Control F5 and it just runs, and it will produce my code that says, all right, right here, hello world. And actually, one thing I am going to do is this is the case where sometimes when I'm sharing my video and presenting, it goes a little bit slower. So I'm going to turn off my video, but you'll still hear me talking. Okay, so we did Control F5 just to show that hello world runs. Yes, there we go, hello world. Okay, it's working. So we don't need the boilerplate code here. If you want to know more about this, you can click this link to see where did my namespaces go and where did my main method go and that sort of thing. But I want to show a couple of things here. So first, I'm going to just type a list, and we'll just call it a list of strings. And we'll just say new. And by the way, that's a C#9 feature, target type new expression. I don't have to say new list anymore because it already knows what it is. And right off the bat, you notice if I compile this, the build succeeded. Now, if you're watching very closely, you may say to yourself, well, wait a second, how did the build succeed? Because normally I have to have like a using statement up above. I used to have to specify a using statement for system collections generic. Like, how is this working without a using statement? And I'll get to that in a second. But what you're going to see is that in previous versions, this wouldn't work, because if I look at the CS proj file here, notice these this setting I have right here, implicit usings enable. If I come in here and say disable, and let's just do another build, notice how just by building that, build failed, okay? And if you look at the build failed, it says, hey, I don't know, namespace for list. I'm suddenly confused. I don't know how to find my namespace, right? And so that instance I gave before, like, how does it know how to find the namespace? It's because it was adding the namespace with this implicit usings. And again, I'll talk about that more in a second. While we're here, I'm going to disable null checking because I don't want it to distract from some of the demos we're going to do. Now, I want to show this in a little bit more depth. And some of these features I'll be deep diving a little bit into. Some of them I'll just show quickly. But I'm going to open up this, I'm going to start this person class here. And in this person class, actually, let me back up a little bit here. What I'm going to do is I'm actually going to have both a person and an address. So I'm just going to add a snippet here. And I'm using records, so nothing special about the syntax. We could do this in C#9. So I have a record for person. It's got first name, last name, address, and here's my address down here, which I have city, state, and zip. And I'm going to add a new property right in here. And I'm going to use the date only property, and we'll call it date of birth. And notice that right here, it's in the system namespace, so this all works. But if I get rid of this, suddenly, again, okay, I don't know how to find the system namespace. So what we can do here is a couple of things. Now, number one, I showed before how we had the implicit usings. That would have been one way to fix it. But there's another way we can control the namespaces. I'm going to add a file, which you can name anything you want. I like to name it usings.cs or maybe global usings.cs. And what I can do is I can say using system in here, but that's just for a single file. If I put the word global in front of it, I've got to spell it right, obviously. Then what happens if I go back here, suddenly you notice that red squiggle went away and now it's happy. So if I say global and then using system, it's equivalent as if I put a using system on top of the file everywhere. So right in here, this is the first feature I want to point out, which is in C#10, we have this concept of global usings. And so this is a really helpful thing because we can put some of these using statements out there as we go. Okay, so for example, I have a bunch of using statements I want to add globally. And let me put the global keyword in front of all of them. We go right there. And so now I take care of the system namespace. I take care of the collections generic namespace. So the person class is happy with date of birth. The program.cs is happy because I got my system collections namespace in here. And this is a nice thing that allows us to do. Now, I want to point out one other thing. You might be saying, okay, well, here, this was very explicit. I could see exactly what using statements were being included globally. But when you were using this implicit using statements here, you might have been thinking to yourself, well, it seemed a little magical. I mean, I guess you had the generics namespace that got included in there, but I'm not exactly sure which namespaces got included. So let's look at that a little bit more deeply. So what I'm going to do is, just for clarity, just for temporary, I'm going to come here and I'm going to comment out all of these global using ones. And I'm going to bring this back. We're going to say enable global usings. Let's just build to make sure we're good here. And then what I'm going to do is, and also just wanted to point out that, yes, here we go. We're good. Oh, and I also, actually, let me start out also showing one other example here, which is I'm going to do the person class here. Oh, sorry. So person P, and we take that out for a second. And we're going to say new, and then we'll say Steve Michelotti. And we'll just give a year here. I was born in 2000. Actually not, but let's just pretend. And we'll just give a null for address for now. Now, one thing you'll notice here is I'm getting the error, right? I've got the squiggle because I don't have the namespace. And I could go ahead and then I could add the using statement at above, and that would work. But again, we want to understand, like, how are these potentially added? So I want to show one thing here, which is, let me open my terminal here. And let me, oops, sorry about that. Let me clear that out. So I'm going to cd into my folder here, and I'm actually going to go into the obj debug folder, into the .next sys folder. And what you're going to see here is there's actually this file that's, in addition to like the, my exes and things like that, I've got the CS10 demo global usings .g.cs. And if I just have a quick look at what is in this file, you're going to see that it is these namespaces right here. So when we do that enable global usings enable equals true, it's going to default to these, what is it, 6 or 7 namespaces it puts in there. And sure enough, there's system and there's a generis collection. And so that's how those items were working before. But what if we want to actually add to the list of things that get generated? What I can do is come into my CSproj file, and I can add an item group for this. And in the item group, I can have some using statements in here where I say include, and I would include CS10 demo because that's the thing that made this work right here. This using, it's equivalent to having this in a global using, that CS10 demo. And then I can also remove certain things. So when I look at this one right here, I say, okay, well, threading tasks, I use that all the time. Obviously, anytime you use async and await, you need that. But system.threading, I don't really need that. Like, that's not that common that we use that. We can include that explicitly when we need to do that. So you can come in here and do something like using, and then you can say remove, and you can say remove system.threading. So a couple of things here. Let me go over to this program.cs. I'm going to comment this out, and yet it's still going to build successfully. The red squiggle went away, even though I commented this out because I included it in here. And sure enough, if we come back and let me cat the global usings.g.cs one more time that was auto-generated, you'll notice that this has now been inserted because I included that in my CSproj. And the system.threading that was previously there is no longer there. So you can still control what is auto-generated. So again, for me, a lot of times when I'm showing these things, I want to take the mystery out of it by going a little deeper to show you what's actually happening under the covers. So again, that's really personal preference. So actually what I'll do a lot of times is I'll come in here and disable this, and I'll enable global usings here. I feel like, for me, again, it's just a personal preference. I like to put it in global usings.cs because to me, it's more discoverable. I have it all in one place. I don't have to guess what was enabled with the implicit usings and that sort of thing. And you can technically use them in conjunction with each other. That also works. But like I said, I usually like to control it here. The choice is yours. I just want you to be aware that either is available. Okay, now I don't know if I should be pausing here. If there's questions, I'm not necessarily going to be monitoring the chat, but you shouldn't necessarily be shy to, unmute yourself and shout it out if you do have a question. I'll pause for you. Okay, so that is the first feature, global usings. Let me close this and come back to the person.cs here. Okay, now actually this next feature I personally love. Other people may not, but one of the things that the C# team realized is they started looking at all the curly braces that are all over the place in C#, and they realized, like, just by every single file you do you typically has a namespace at the top, then you have a curly brace to start, and you have a curly brace to end, and you have all this indentation here that has to happen because of that. And they started wondering to themselves. I actually saw a talk a couple years back with Mads, and he was talking about they're trying to determine how many gigs of white space they're responsible for being checked into source control systems all throughout the world in the last 20 years, just because of all the indentation that needs to happen. And the 99.99% of the cases, you just have one namespace in a file. Sure, you could technically have multiple, but it's rare that you see that happening. And so wouldn't it be nice if you could just put the namespace at the top and not have to do this somewhat artificial indentation? So now you can do that. Now what I'm going to do is I'm going to just put a semicolon after this line. Watch what happens when I do this. I'm just going to type semicolon. And did you notice what happened? Visual Studio eliminated the curly braces and also moved these things in. And it's equivalent. Nothing's different, right? I mean, the code still runs. Nothing's different, but it effectively just eliminated the need to do that. So if you just do namespace and your name at the top with a semicolon, it's going to be the equivalent of, okay, everything that comes under this in the file is going to be inside that namespace. And so this feature right here is another C# 10 feature. And this is just called file scope namespaces. And one of the things you're going to see me do here is I am going to be putting these little comments. I'm going to be sprinkling these comments around the code, like these comments for the C# 10 feature, because I'll make the code available for download after the talk. So you can sort of recreate all of my demos. So there'll be cases where, all right, I'm done with this code. Let me move it out of the way. Instead of deleting it, I'll just comment it out or put it off to the side. So again, you should be able to recreate all the demo code I'll make available here. But I'm going to be sprinkling in these comments so you can follow along the demo code when you get it. Okay, let's keep going to the next feature. Okay, so let me comment this one out because we don't need this right now. So I'm going to talk about some string features next. So I'm going to come in here. We'll do string greeting, and we'll just say this is hello. And notice that I declared that as a constant string. I'm going to do this again, and then we're going to say this is a message. I'm going to use string interpolation, which you see with the $ there, greeting, and I'll say greeting Steve. So it'll be like, hello, Steve. So let's run it. Let's just verify it all works. Okay, there we go. Hello, Steve. Now, when you look at this, this actually is a new feature of C#10 called constant interpolated string. This literally does not compile in C#9 or below. Does not compile. In fact, let me prove that to you. Let me go just change this to .NET 5 real quick here. And if we do a build, you're going to notice that this is not going to work. I'm going to get an error saying interpolated strings not available in C#9. Please use 10 or above. Constants had to be constants, and string interpolation is considered like string is considered to be like string concatenation. It is string concatenation, and so it's not a constant. It's concatenation. But people would often look at this and they're like, yeah, but the variable I'm using in my string concatenation is itself a constant. So why can't I do this? And C# team looked at this and said, huh, good point. Yeah, you should be able to do this. So constant string interpolation is only legal, only available in C#10 when the variables you have here are constants themselves. So this variable greeting, the two requirements are it itself must be a string, can't be an integer or anything like that, and it also must be a constant, which we have right there. It's a constant. So that is a nice to have feature, constant interpolated string. Okay, now we're going to keep going on this theme of string interpolation. And this next demo, I'm going to go a lot deeper. Now, again, some of these demos I'm going to go quick. I'm not going to go that deep. I'll warn you in advance, we're going to go down the rabbit hole in this next demo, okay? So let's talk about this a little bit. Let's do this. I'm going to put a couple of log statements here, and let's just make sure they run. And you can see I've got this thing that says some cool log message. I've got a date. I've got a time. Here I don't have a date. I just have the year of 2022. That's an integer. And again, I'm putting the time right here. And if we look at the code that actually went into this, you can see it's both string interpolation. I'm doing a toShort date string there and time string there. Here I'm just doing datetime.now.year and string here. Okay. Now, as we look at this, there's a couple of things that I want to point out about this. Number one, in message one, I'm using a var, and when we'll just kind of naturally do a var, it's going to naturally say, well, yeah, it's string. We're doing string interpolation. But I can actually do something like this, where I change this to a formatable string. And when I do that, it shows some interesting things. So first, let me just make sure it still runs just fine. Okay. But now, with it being a formatable string, let me show you the output we can do with that. So here, let me come in and notice this one right here. I'm using, remember, MSG1 is the formatable string. And by doing that, I suddenly have a property called .format and .argument count. So let me run that and show what that looks like. Here you can see the format is some cool log message at 0 and at 1. And then the argument count is 2. And why is the argument count 2? Because there's 1 and there's 2. And when you look at this format, it kind of looks familiar, right? So if any of you have used string.format, this is what like a format string would look like if you're using string.format. And this is a good indication to you that under the scenes, under the covers, traditionally string interpolation has used string.format under the covers, which, by the way, traditionally has used a string builder under the covers as well. But with C#10, we're going to have some interesting new capabilities that allow us to take more control over that. Now, there's a couple of things I'm going to do because I like to prove things to you. So just for sake of completeness, I'm going to come in here and do a new project. We're going to make this a console app as well. We're going to call this CS9 demo. So this is C# 9.0. And I'm going to select .NET 5 just to kind of prove that we're in C# 9. And I'm going to replace this hello world here with the exact same messages that I put there a second ago. Now, what you're going to see here is I am going to right-click the main method. And notice this thing where it says open an IL spy. This allows us to look at the actual decompiled code, kind of like Reflector would do for us back in the day. So I'm going to open that up, and I want to show you a couple of things here. So if we look at this code in the context of, now, again, I can actually just look at the straight IL code that was produced from the compilation. One thing is nice is you look at the IL with some C# sprinkled in between, but I'm just going to look at the C# representation of the IL. And if you look at this, a couple of things I want to point out is message 1, it's doing straight old school string concatenation with a plus. But with message 2, notice it's using string.format. And it's doing it with these like there's the format string 0 and 1, and the year is to 0 and the 1, and this goes to the 1. And when you first look at this, you may say, well, hold on a second. Like, remember, when we looked at this code is both using string interpolation. It looks the same, string interpolation. So why, when we look at the decompiled IL code and then translate that to C#, why is this one doing string concatenation and this one doing string interpolation with string.format? What's going on here? And the reason is because prior to C#10, C#9 and below, and frankly from C#6, C#6 is when this feature was introduced, it would default to straight up string concatenation if the values you were concatenating were all strings. But in this case, this argument here for year is an integer. So because this is an integer and not a string, it said, oh, I'm not 100% sure, so I'm going to just go back to the string.format for this one. And that is actually why they produce it differently. Again, string.format uses string builder internally. But that is how string interpolation would happen prior to C#10. All right, so now let me close this back. And now I'm going to come back to, let's go back to the C#10 world, and let's once again open this in ILSpy and make sure if ILSpy is not in your current instance of Visual Studio, make sure you may have to install it as an extension. Make sure you do. It's a very helpful tool. It helps you understand what's going on behind the scenes. So I'm going to open it again, and let's put it in the context of C#10. And I went to the, let me come here. I actually want to, let me try this one more time. It opened the list code. I actually wanted to open. Here's my main method. Okay. So in C#10, the exact same code that we have decompiles to something different. It's not using string concatenation, and it's not using string.format. Instead, it's using this new class called default interpolated string handler. And this operates a lot like a string builder, but there's a couple of little differences. So notice it's got two methods, append literal and append formatted. Append literal is exactly what you think it is. It's the constant string, some cool log message in year space. The append formatted is like the variable. That's like the curly brace 0 variable we saw right here. Then we have at space. Then we have the next variable, which is like that curly brace 1. And then remember, the very end of my string had a period to end the sentence, and that's the append literal right here. And a similar thing we see down here as well. And I mentioned that this behaves a lot like a string builder, but actually the default interpolated string handler is even more efficient than the string builder internally because it uses span of t. And these are some memory optimizations that we talk about, some of those point releases that happen in C# 7.1, 7.2 that a lot of people didn't even notice were some of these span of t memory enhancements that if you were writing really low-level C# code, you would take advantage of. If you're not writing low-level C# code, that's fine too. You just get the benefits for the framework authors that put these enhancements in the framework classes like default interpolated string handler.
Steve, can I ask a question?
Yes, please do.
Back before you had append formatted for a function, the toShort time string function that returns a string. I would have expected that to be append literal.
Yes, so that good point. Okay, so I think what we're saying here is because I think in your mind you are sort of applying the rules that I said that the previous versions of C# operated under to the same situation, and therein lies the difference. So just to kind of recap for everyone, so we're all on the same page. If I go back to the pre C#10, that was sort of the rule, right? If these were all strings, this would be string concatenation. This would be string concatenation, and because this was not a string, this would default to string interpolation. If I did this in like the C#5, we see the string format here because this was an integer and not a string. But those rules, it's easy to get those two conflated. That rule was the rule that was following prior to C#10. Now, if we once again look at the C#10, there's a couple of things to just hone in on a little bit here. Let's open the C#10 version. Now, the thing is, this is not a literal. This actually is a variable. So this is the thing. Even though it's a string, yes, but it's not a literal string. It's not a constant string. So a constant string is truly a constant. This is a string that is being created as a result of a function call, which actually is going to be literally different from 1 second to the next. And so that is not a string constant. It's a string, but not a string constant. And so that is an example of, but you raise another interesting point. Let's do a quick test since we're all here. If we were to, I'm going to comment out, that one was a message 1, right? So let's comment out, let's do a message, I'm going to comment this. Let's do message 3. Let's just make this var for simplicity. And let's use a constant to see if it gives us any different behavior. So I'm going to use greeting because greeting truly, we don't need all this. Greeting truly is a constant. So you see what I'm doing here? This is a constant. This is not a constant, this one right here. So if we do this, let's see if it gives us any different behavior. And I've got to actually, it might actually be optimizing MSD3 out of it. So let's make sure it actually outputs it. Yes, there we go. Let's look at it, see if we get any differences. Ah, okay. So what we can see here is it just straight up optimized it, right? Because it was a constant, message was a constant. It was on greeting. Greeting is the hello, right? It didn't even bother. There was our variable right there. So in that instance, because that variable was truly a string constant, it didn't even bother with the default interpolated string handler. So again, different behavior if it's a string versus a string constant. Hopefully that answered your question.
You did, thanks.
Okay, awesome. So I'm going to take that one away just so there's no confusion. Okay. Now, what's interesting about this? I mean, many things I find interesting about this, but let's dive a little deeper here. This default interpolated string handler, this is used by the C# language compiler at compile time, not at runtime. So it internally uses this stuff. But we can actually use this in our own code as well. So what I'm going to do, just to go a little deeper, I'm going to take this code. I want to set it aside, and we're just going to call. I'm just going to extract method and say, intro demo. And it's kind of just like, it's almost like I encapsulate it in a region block. I want to move it out of the way, but I don't want to delete it because I want people to recreate the demo. But I'm going to clear some space for myself to do a new demo up at the top as we go a little bit deeper here. Okay, so I'm going to do a couple of things. Number one, I'm going to add a new class called logger.cs. And in this logger class, I'm going to actually no, not that one. Here we go. I have a logger class, and it's a very simple class. Let me just show you what I've done here. I've got a constructor that takes a log level and sets it. And then I have a log method that takes a level and says, okay, if the level is less than or equal to the current level, go ahead and output that log level. And the log level is, typical error warning, none. Okay, so this code right here, nothing C#10 in this code. It's there, okay? So what I want to do is show how we can take control over this code. So let me close up this one so I don't get confused. Let me come back to my program one. Okay. So I'm going to put some logger statements here. Now, if I have info as my log level, then all three of these messages should output. Let me prove that to you. Sure enough, info, warning, and error. But if I change the log level to, let's say, warning, then info should no longer be shown, only warning and above. So warning and error should show, but no more info. Sure enough, warning and error show. And then if I show a log level of error, I think you know where this is going. Warning and info should be suppressed, and the only ones being output there is error. Okay, good. All well and good. Pretty kind of standard logging functionality. But some things to be aware of, and let me just set this to info, kind of something in between. But there's a couple of things going on behind the scenes, which is, yeah, that's cool. We're only outputting error, but all the string concatenation is still happening. So even when I have sorry, I actually wanted this as warning. So even if I have warning, the string concatenation on the info line is still taking place. The operations, I'm still taking compute cycles to perform string concatenation, even though we never ended up logging the info message when we're set on the warning level. So because of these new string interpolation features we have in C#10, we can actually take full control over not only how string concatenation happens, but also when string concatenation happens. So let's start out with this first one, which is, let's say we want to add a feature to say how string concatenation happens. And we're going to do this in the context of showing how you can actually use a interpolated string handler yourself. So I'm going to come in here to my logger class, and I'm going to add a log interpolated string handler. Now, this is a little bit different how some things work in C#. Normally, you would say, okay, if you inherit from a certain interface or base class, then the methods have to conform to a certain contract. This works a little bit differently. This one is you have to put the attribute interpolated string handler above. And if you do that, then that means you're required to implement append literal and append formatted. Those are the two special, and those should look familiar because I showed you those in the earlier demo for the built-in classes. And you might say to yourself, well, why didn't they just have this as an interface that has append literal and append formatted in the interface? And the answer to that is going to become clear in a few minutes, but in short, it's because the method signatures can actually change and what the parameters are. So that's why they had to make that design decision. I'll show you that in a second, but right now we're still on all the defaults. So what we're going to see with this interpolated string handler is I'm saying, okay, I prefer to use a string builder, just to make the example clear. So I'm actually going to be using a string builder in this, and you can see I have a private instance of the string builder. So if anyone calls append literal or append formatted, they're going to be using this string builder append method right here. And you're going to notice I just have these console write lines sprinkled throughout, because not because I would actually put that in a logger in production, but because I want you to understand what's going on for the demo as we work through this thing. Okay, and so what I'm going to do here is we are going to make this a log interpolated string handler. Instead of a string here, we're actually going to change this string to this type right here. And because MSG is no longer a string, it's actually going to call this getText method, which is defined down here. And all it's doing is delegating to the string builder's toString method, as if we were taking full control over that string builder method. Okay, so let's run this to see where we're at here. Now, I want to make sure everyone's kind of following what's happening here. As we look at these statements right here, what we're going to see is these are actually the statements that are being outputted for the info message. Now, you're not actually seeing my cool info message being outputted, because remember, that's being suppressed. The log level says don't write that log level if that's what's in there. But the string concatenation is still happening. Again, we'll get to a second to control when string concatenation happens, but at least I'm showing you that we're taking control over how the string concatenation is happening. We're using a string builder, we're using append literal, append formatted, all that kind of stuff. Then down here in this segment, this is the segment for that warning message. There's the warning message literal, there's the append format, there's the literal for the period, and then the one at the very end, the actual final message being output. And the same thing here, this is what we went through for the error message. There's the literal, there's the variable, there's the literal, and in here is the entire output method. Okay, so we have taken control of how string concatenation has happened, but now we want to go to the next step, which is we want full control over when string concatenation happens. Because again, if I'm not going to log the info message, for example, well, I certainly don't want to go through the trouble of like doing all the string concatenation required to construct a message that I'm not even outputting, right? Okay, so, and again, just to make this super clear, let's go to error. And when we run it, only the error message is outputting right here, but all three are going through string concatenation. And that's the issue we want to fix on the next one. Okay. So let's see how we can do this. Now, a couple of steps here. In the log interpolated string handler down here, I'm going to add a private Boolean variable called enable. And right off the bat, just by adding a member variable, notice I'm getting a compilation error. And the compilation, well, how are you getting a compilation error? All you did was add a private Boolean. But the compilation error is saying, well, this log interpolated string handler is a struct, and the struct has to be fully assigned, and this Boolean variable has not been assigned. So you've got to make sure that it is assigned. So what I'm going to do is I'm actually going to come down here. Instead of an expression body membered for my constructor, I'm just going to use traditional constructor body, and let's put it in here. And for enabled, we're going to say in the constructor, we're going to assign enabled by saying if the level is, let's see, we want to make sure we're passing in the level. So yes, we have to add parameters here. So I'm actually going to add some additional parameters of the logger itself and the log level. Those are going to be passed in. And so if the level that is passed in is less than or equal to whatever the current level on that logger is, that's how we know whether it's enabled. And by doing that, what we can do is on the first line of each of these append literals, I can say if not enabled and return. And I can do that for each of these right here. Bear with me, this is all building up to here. And so we will suppress all of those things from running. Now, another thing to keep in mind here is you say, well, oh, hold on, some magic just happened. You just sort of like added these parameters like onto the constructor. Like, how are you getting away with that? Like, how is the compiler supposed to know what's happening here? So in this instance, we need to tell the compiler how to deal with these two extra parameters. The compiler by default knows how to deal with these two parameters, literal length and formatted count. Those are just like built in. But if we add anything else onto that, we have to tell the compiler how to do this, how to like know how to like process this. So on this log interpolated string handler argument here, I'm actually going to put a interpolated string handler argument, a little bit verbose, and we have to specify what these two things are. Okay. Now, even what I typed here may have been slightly magical. It might be a little bit odd, but when you do an empty string like this, it's referring to the instance of the class itself. So this logger class itself, it's referring to an instance of the containing class. So that empty string equals the instance of the logger, which is this thing right here. The compiler is automatically going to pass that in. And then this one here, this level, this must correspond to a variable here. So if it says level there, it's got to say level here. If I say, if I say level X, notice how it gave me that compiler warning? It says, I don't know what level X is. That's not a valid parameter. You don't have level X. That's not valid. But if I make it level, it says, oh, yeah, I can find that. It's good. Now, sometimes when people see that for the first time, they're like, whoa, wait a second. How did the compiler do that? Like, how does the compiler know anything about what's inside of double quotes? Well, now we have this magical Roslyn compiler. We can do all this great stuff at design time. And so that's how, in previous years, like being able to do that trick where it recognized something inside the double quotes was not valid. That was beyond our wildest dreams to be able to do something like before Roslyn. But now the C# team just does that stuff all the time. Okay, let's actually go ahead and run this and see what happens here. Now, it's a pretty cool result actually. So what we see here is we did not go through all the append literal and append formatted. That did not get executed for info and for error. Oh, sorry, it did not get executed for info and warning, only for error. Now you might say, well, hold on, but we did have 3 constructors. I am seeing the constructors for all 3 of those. That is true. We'll address that in a second. But as far as the actual string concatenation, you're only seeing actual string concatenation for those 2. So already we've like optimized this in a pretty cool way. And the reason it didn't come into those other ones is because we had this like if statement right here and here that were blocking it from going into the string concatenation. But there's even a more elegant way to block, I'm putting block in air quotes, that string concatenation, which is we can actually come in here and add an out parameter to this log level, okay? So what I mean by that is this. If I come in here and after this level 1, I actually give an out parameter, out bool is enabled. And now I don't even need this enabled one here. I'm just going to assign this out parameter is going to be assigned right here. I was wondering what I was doing wrong. I have an extra L there. And now it doesn't even need these. So I'm going to comment out these if statements. So there's no longer an if statement blocking the code that you see. But watch what happens. Still, the string concatenation did not happen. I didn't even need the if statement to block. It didn't even attempt to go into these methods. Because I assigned is enabled true, and it's going to be true or false depending on where the log level is. For info and warning, it was false. It didn't even attempt to go into these methods. So in effect, and by the way, I don't even need this console write line, right? That's just to really illustrate what's going on. So I could actually simplify those lines of code much more easily. So let's just take this. And I can just simplify those down to one-liners. So we're just using expression body members that we previously had. Even this one, I don't need this line anymore. And since this constructor is only one line, while we're at it, we might as well make it an expression body member. Sure, what the heck? Let's make it more concise syntax and clean that up. And everything is good to go. And we did not even bother with string concatenation for the info message or for the warning message. We only performed string concatenation for the error message. When we output the error message, we took full control over how the string concatenation happened because we used a string builder. We could have used span of t if we wanted to. We are in full control of what is happening here. So I warned you in advance we were going to go down the rabbit hole on that one. So that was a super deep dive into these new features that we have for string interpolation. But just keep in mind, these features right here, this is what we're talking about when we are talking about this concept of interpolated string handlers. Okay, so I'm going to come over here. I'm going to set aside these 4 lines of code into the logging demo. Before I continue, are there any questions I can answer about string interpolation before I go on to another topic?
So is there a way to get, I'm trying to think, there's no way you can get back out the variable name that's used. And I'm not sure. So, I mean, I guess where I'm going with this is, with most of your loggers, you want to use, you want to provide a name so that the logger, when it exports, when it's put someplace like a file, it can actually be configured to have variable names, and then you can filter by the variable names later down the road. So what you would normally do is not use string interpolation, and instead you provide the variable names, and then pass in the old school way of doing the passing in the variables. With what you're showing here, is that possible? You can just use string interpolation and still somehow maintain the variable names?
I want to make sure I'm fully following your question. Are you talking about like structured logging type stuff?
Yes. Thank you. Yes, that's exactly what I was thinking.
Okay. Yeah. So I'm using logging here as sort of an example to demonstrate string interpolation. What you're referring to is we have some instances where a certain library, I think App Insights might do this, where when you use like a traditional C# string interpolation string or even string format, it's kind of smart enough to understand, oh, these variables are things I can filter by. In that paradigm, you shouldn't do anything different than what you're doing today. You should still follow this paradigm. I'm just using the logger to show in some instances of string concatenation that you would be able to do these optimizations. So in that instance, these variables, like if you have a string concatenation instance on that logging where hey, you're going to like be filtering by some of the variables, don't do anything different. You should do exactly what you're doing today. But there's also some of that message may be concatenated in that actually you're not going to be filtering on. You're just doing, straight up, string concatenation to get, the logging message. In that instance, yes, this is a feature you can use. So this is sort of a lower level feature depending on your context. This is not even something you would necessarily use for logging at all. Maybe you're using it for logging. Maybe you're using it for a completely different feature, not even related to anything having to do with logging. Maybe you're creating a, I don't know, CSV file or something. But in the paradigm you're talking about for structured logging, don't do anything different. Keep following the same documentation you're using for whatever structured logging library you're using.
Got it. Okay. Thank you.
Cool. Okay. Great. Okay. So this next demo is going to be a little bit simpler. So let's bring back our person class here. What I'm going to do, and actually I don't even need this date of birth anymore. Let's take the date of birth away and just use first name, last name, and address. And on this one, what I'm going to do is let's make sure we are knitting a person. So there's Steve Michelotti. I'm just doing like Main Street, Baltimore. And we want to be able to run it. So let's just person.toString. And what we get here when we output the person.toString, this is the default toString that records give us. So if you saw me do a C#9 presentation, I talked a lot about how this is a nice kind of formatting thing that C#9 gives you with records, where it gives you a curly brace and just property name value, property name value. But we have an instance where we actually want to look a little prettier than this. So what I can do is I can come in here and undo that. I can give a curly brace and let's override the toString method. And in this case, I actually want to come in here and say return. And let's just say, first name and last name. First name, last name. And we output it. It's all good. Now I just have a nicer, maybe I don't want all that detail. I just want simple first name and last name. Great, I can do that. While we're at it, what the heck, let's make it an expression body member. We don't need all the curly braces. We can just make it more simple, like we're using C#8 or 9. Okay, there we go. Okay, all good. Now what I'm going to do is I'm going to come in here and I'm going to create a new class. Instead of person, it's going to be called business contacts. And we're going to, instead of first name and last name, in addition to that, we're going to have a company name. But we're going to inherit from the person class. So whatever we gets passed in for first name and last name, we'll use that. We'll pass in address. We'll pass all those values to the base class, just like we would do in normal object-oriented programming. But when we come back here, let's actually create a business case here. So let me come in here. We're going to call this business contact. And instead of Steve Michelotti, we'll call this Bill Gates. And I'm not even going to bother with an address right here. Oh, let's actually call this something else too. Business contact. And so let's take this business contact here and do the toString method. Okay, what are we doing wrong? Oh, address. Right. Okay, I forgot to. I don't want him having an address. Oh, actually, I do. I'm just going to pass in null for it. I forgot to add company name. My fault. Someone's got to help me out here. It's Microsoft. All right, now what I'm doing right. Bill Gates, Microsoft, and null. Bill Gates, Microsoft, null. Oh, what did I do wrong here? Address. That should work. Last name, address. I spelled it wrong. Case sensitivity, people. C# compiler telling me when I'm doing something silly. Okay, now here's what I wanted to point out. Business contact is inheriting from the person record. The person record has this nice toString method, but hold on a second. We got here, and now we have this whole toString method. It's not using my nice toString method. And this was something that you were just kind of out of luck in C#9. In C#10, what we can now do is on the override, we can mark this as sealed. And when we do that, it says it's sealed. You can't override the toString method. And now the subclass of the record will use that one right there. So you have your choice. You now have more control over how you want the toString method to happen. But this is specific to a toString. So again, like seal toString on records. Only for toString, only for records with inheritance, not a life-changing feature, just one where you don't have it, you may get confused because you don't have to do the same toString all over the place. Okay, moving on. So we have extensions. So with this extensions class, we are going to add some methods to it. And I'm going to have is Maryland, and because this is an extension method, the class has to be a static method itself. And you can just say we're going to pass in a person. If the state of the person's address is Maryland, then is Maryland is going to be true. All right, so let's come in here and let's add a console for it. Is Maryland, and we'll say person.is Maryland. And yes, I do live in Maryland. And so when we run it, we get is Maryland is true because Steve Michelotti is in Maryland. And this is a feature that you can see I even have property pattern from pre-C# 10. I think this is like C# 8 or 9. Now the thing is, a lot of people would look at this syntax and they find it to be confusing because you have an opening curly brace and another opening curly brace, and then you have these kind of weird double curly braces, closing curly braces at the end. And so I'm actually going to comment this out because I don't want to delete it. I want you to just be able to see the before and after. People are like, wouldn't it be a lot nicer if I could just do address dot state and get rid of all these extra curly braces and get rid of this extra curly brace at the end? Wouldn't that be a lot nicer? And the answer is yes, that's a lot nicer. And so this is a feature in C# 10. And this is for extended property pattern. And by the way, yes, this works when it's null as well. So if address is null, you don't have to worry about this throwing a null reference exception. Null will not be equal to Maryland, and the compiler will make sure to handle that for you. So that's extended property pattern C# 10. Okay, moving on. Don't hear any questions. We're going to keep going here. So back to the program.cs. We're going to come in here and, oh, actually, no, I'm going to put this in that's the wrong class. I'm going to put this in the extensions class. Is valid name. We're just going to say if the name length is greater than 2, it's valid. And we can look at these variations for is it valid. Okay. Now, this is just the hard-coded constant string of Steve is valid. This is Steve concatenated with a space, concatenated with, and then this is string interpolation. Pretty good guess they're all going to be valid because all these strings are longer than 2 characters. And sure enough, all 3 are true, all 3 are valid. Okay, not too interesting yet. What we have in C# 10 is an ability to now see a little bit more about what the incoming code looked like. So what I can do is I can add another parameter onto this method called name expression. We'll set it equal to null by default. And on this, I'm going to put an attribute to help the compiler out called caller argument expression to represent the name variable here. Did you notice that? It gave me I did name with a typo. It has a C at the end. It gave me the green squiggle because name is N-A-M-E. So if I take that C away, green squiggle goes away. And this is actually going to give me some optional information about this. So I can come in here and say console write line. I'll just do a little string interpolation thing here. I'm going to use the name of argument, name expression, and then the value. Notice I'm not even changing the caller. I'm not sending a second parameter in. The compiler is going to send this parameter in for me. I'm not sending it in. I didn't change what it looked like to call that method. Now, all 3 still evaluate to true, but notice the name expression, it actually knows that was a constant string that got sent in called Steve. Here it says, oh, here was a string concatenation that got sent in, Steve, and then a string concatenation on the space. Here's a string interpolation that got sent in. So how many times we're like maybe in the logging statements or whatever, we look and we're like, oh, this is null, or like, well, what was the expression that sent that value in? Not only can you see the value, but you can also see the expression of what that value looked like. Pretty cool compiler feature, pretty powerful feature. And you can see some of these features actually being used in the framework itself. So for example, if I do argument null exception and throw if null, I can actually send in like this variable of name, and actually it's going to know itself what that is. So those types of things, let me just do this real quick. I'm going to show a quick example of this. RP2 equals person with first name equals null. And this is using record initializer syntax that we had in previous versions of C#. And so we say P2 is Maryland, or no, is valid name. P2.first name is valid name. We throw the argument no exception, and it even knows the parameter name was named. So it's even some of the built-in classes, it's helping out with what these things look like, what these things are called, and you see different examples of that as well. Okay. So we're going to set all this aside as well. All right, we're almost hitting the home stretch here. So this is going to be all.
Question, Steve.
Yes, please.
That last one, it's kind of blowing my mind.
Yeah.
Is that the caller argument expression? I'm just thinking about performance. Like, is it using reflection for that, or is it using something that would be more efficient, like it's maybe compiled in? It doesn't have to figure it out at runtime or anything.
Yeah, that's the beauty of it. Because Roslyn is now so enmeshed in the compiler itself, they're able to do these things pre-generated without using reflection. This is stuff that wouldn't have even been possible years before Roslyn. Like, even when I'm giving those examples of how, like, you know, when I do like something in the double quote, how could the compiler possibly know a string inside a double quote is actually a compiler error? These are things that would not have been possible years ago to be able to do this without using things like reflection and things like that. So yeah, it's actually the compiler throwing in those efficiencies for us.
Very cool. Thank you.
Okay, let's keep going here. So, all right, let me close this up and get some space up at the top for the next demo. Okay, before C#10, we could do something like this, where I could have a delegate here, a lambda, and pass in a number, and we just say whether it's even or not. So I'm going to send 21 in. Of course, 21 is not an even number, so it's going to be false. And this worked just fine. Now I'm going to copy this. I'm going to comment it out. Now, if I make this var, still works. All the code, nothing different about how it functioned. But this is actually a new feature in C#10. Inferred natural type on lambda, that's the var keyword, would not have compiled in C#9. Would not compile in C#9. That's one of those examples of like, wait, what's the big deal? I don't see what the big deal is you did. You just added vars, type inference. The type inference engine in prior to C#10 was not strong enough to be able to do what it just did. So it's one of those things like, why doesn't it work? Well, yeah, it should work. It's just the compiler team didn't have a time to get to it. Now it just works. So it's one of those things you only kind of notice when it doesn't work. Now that it's working, it's like, oh yeah, cool. Like, I kind of figured that would always work. And also like the ability to use attributes on lambda. So if I'm just going to use pure because it's kind of a generic attribute kind of thing. That's also a new feature. So another new feature is the ability to be able to use attributes on a lambda parameter. Before, it would be frustrating. Why can't I use an attribute on a lambda parameter? Well, yeah, there's no reason you shouldn't be able to. It's just that the C# team didn't have time to get to it. And let me just add the namespace so that no one is thrown off by the red squiggle. So again, that's an example of a feature like you're probably not even going to really notice. It's just you notice it if it isn't there and you're trying to use it, that kind of thing. Okay. All right. Now I know we're getting a little bit close on time, so I just want to show a final demo here. I'm going to put that down a little bit lower. And I want to talk a little bit about struct versus classes. So struct is a value type. It's stored on the stack. A class is a reference type. It's stored on a heap. Struct logically represents a single value. It's immutable. It's typically very small instance size, like a matter of bytes. It's short-lived. Think of it like integers, things like that, whereas classes, everything else. Structs can have boxing and unboxing. So the canonical example is just taking an integer, putting it on an array list. Every time you do that, or you cast it to an object, boxing and unboxing. That does not happen with reference types. If you're doing a class, that does not happen. You can cast any class to an object. There's no boxing operation that happens. It's just a lightweight cast operation. Struct, that's not the case. You have to deal with boxing and unboxing. Okay, so there are some features. Oh, didn't mean to do that. So there are some features at just C#10 to bring structs with a little bit more parity with what we have in classes. So what I'm going to do is I'm going to add a new class called point.cs. I'm going to make this class a struct. And I'm going to add a couple of methods to it right here. And I'm also going to add a constructor to it. So let's generate a constructor right here. And in our program.cs, point p equals new 2, let's just use 2, 4. Okay. Okay, there we go. We're outputting 2, 4. And actually I'm going to set this aside as well. And I don't want that getting in the way of the output. Okay, now so far everything I did is pre-C#10, all legal and pre-C#10. Now, I just added a parameterless constructor, but we need to make sure it's fully assigned. So what I'm going to do is a couple of things here. I'm going to say this.x equals 1. Just like think of this like a default value. Now, this is still giving me an error because it's not fully defined. I must define y also. I must assign y also. So when you have a parameterless constructor, I'm just setting them as defaults just for completeness to show like that it works. All right. So now this fact that we can do a parameterless constructor does not compile in C#9. This is a good example of like constructor. You're saying, well, what do you mean it doesn't compile? Like, yeah, you can't have parameterless constructors on structs prior to C#10. A lot of this is just getting language parity to structs. Classes, of course, parameterless constructor is no big deal. If we come in here, we can do point P2 equals new. There it is, parameterless constructor 1.1. Okay. Now, I also want to point out that on this one right here, we can have a field initializer for y if we want. So we can come in here and I can comment out this constructor. I can comment out that assignment for y. We have an error again, but I could also do it right here. That's also a new C#10 feature. Struct field initializer. Does not compile. But it all still works. And again, it's one of those things you like, what do you mean it doesn't compile? Like that is just certain things would not work. Now, another gotcha to be aware of. Let's say I had 0.3. This is the one that throws people off. I'm just going to assign this default of point. Usually when I ask people to say, okay, take a guess what you think this output's going to be, people will say, oh, well, this is just the default of the point class. So that must be the parameterless constructor. So it must be 1.1. Nope, it's 0.0. So that's a very odd kind of curiosity of this, which is if you use the default keyword, it does not use the parameterless constructor, it does not use any of the constructors, so it kind of just falls into like the initialized value. In fact, it doesn't even recognize this because it's not. This actually gets assigned to the parameterless constructor, which it's not using. So that's just something to be aware of, so you don't actually accidentally fall into the kind of a trap there. Okay. Now I see we're getting close on time. Is this? Am I just a quick time check? Am I hitting my time limit?
No, you're good. We can go on a little longer, but
okay.
You know,
I have another 5-minute demo I'd love to show, but I just want to make sure I'm not keeping anyone because I know on the East Coast it's getting a little bit later. So let me show my final demo here. Actually, 2 more demos. But
that was very scary, by the way. I'm kind of scared of the default there.
yeah, exactly. That's
what I'm looking at that code. I wouldn't expect somebody to be able to cheat and get away with creating one of those objects without my settings that I intended for. So that's definitely scary.
That's right. That's absolutely right. Which is why I make a big point in pointing that out, so everyone is aware of that. So that yes, that is something that has to be like accounted for. Okay. Let's see. Here we are here. So what I'm going to do is I am going to go back to my point.cs class. I'm just going to rename the point struct because I don't want to delete it, but I want to create a different point class here, which is public record point, where we're just going to have an X and a Y. Okay, and then in here, what we're going to do is we're going to put, okay, I'm going to add a distance property in here. This is distance from origin. Okay, so we're gonna actually, and I don't even need to use these right here. Let's just comment these out. Let's just do console right line of P to make sure we're compiling. And there it is. It's giving us X and Y, and it's giving our default toString that record nicely generates for us. Now, in addition to this, we have some enhancements with deconstruction. So all of this code works prior to C#10. We are using the deconstructor to get these variables assigned. So we have declaration here and assignment here. Here, we're using a deconstructor to do declaration and assignment all on one line. And all of this is going to work just fine. So we can see that x1 and y1 got deconstructed, x2 and y2 got deconstructed. All this code is legal in, I think, C#8, definitely C#9. Well, one thing you could not do is mix the two. So again, I'm going to repeat that just because I did that fast. In this first example here, we have declaration up here of x1 and y1, and we had assignment down here. In the second example, we had declaration and assignment all on the same line. There's var x2, var y2, all on the same line. Both of those work in previous versions. But there's one, but if you tried to combine them, it would not work in previous versions. So what do I mean by that? Let's say we have x2 and var y3, and let's deconstruct that. And I'm just going to copy this. And this is x2 and y3. This is now the ability to mix the declaration and assignment in same deconstruction. And I'm not even going to bother to type does not compile to prior to C#10, but that just works. So again, I'm mixing them. Here, for x2, I'm doing assignment, but I'm not doing declaration because it was declared up here. If for y3, I'm doing both declaration and assignment on the same line. So I'm kind of mixing them together in this example. This did not compile in previous versions of C#, now it does. Again, it's one of those features that you probably won't notice. You kind of just notice if you tried this in a previous version, it didn't work. People got all mad with the compiler team. It's okay, we'll fix it for you. Okay, now, one final demo I want to talk about with this point class is records are classes. If you saw me present on C#9, you probably heard me talk about a bunch of times records are classes. And if I prove it to you by looking at ILSpy right here, let me open a fresh version of ILSpy. You're going to see that the record, and let me go C#8, so before we had records, the record is a class. It's a reference type. Okay, now, what we can now do is I can say record struct. That was not something we could do prior to C#10. Now let me open it again in ILSpy. Just like that, it is now a struct. It is now a value type. It is now going to be stored on the stack, not the heap. And that is not something. So we added this great feature in C#9 records. This is supposed to be this immutable type, act like immutable types, and yet itself was a reference type. So now you have the ability to determine whether you want your record to be a reference type or a value type, i.e., a class or a struct. And not only that, but let's add this. Like I'm going to add an increment method here, public void increment. And we're going to say that this is this.x plus plus. Okay, all good. Now let's say we truly want this to be more of an immutable thing here. Built's fine, no red squiggles. We're going to change this to read-only record struct. And just by doing that, it's going to say, no. Now that's a compile error. You told me you want this to be a read-only record struct, so we're not going to allow you to mutate the state of any of your properties here. So I'm going to comment that out so we can build successfully. And once again, if I look at this in ILSpy, what we're going to see is the compiler, not only is it still, of course, going to be a struct. Actually, let me go to previous version. Okay, I was expecting, yeah, this is in earlier versions. There you go. It's actually adding the attribute here, depending on what version you're trying to get it to masquerade as your IL. It's actually adding this read-only keyword right here, which is preventing read-only operations. So this is another new feature in C#10, read-only record struct. So a couple of new features. One is just the fact that you can make it a struct. Another one, you can make it read-only. Okay, so we covered a lot of information. There's some other, believe it or not, that's not even all the new enhancements that were added to C#10. It's just these other four. We're not really demo worthy in my mind, or not stuff you're going to use every day. But I'll also make the PowerPoint available for download. So you can click the links here so you can go read about those features as well. We covered demos for all 12 of these. We talked about global usings, file scope namespaces, lots of interpolation, the override on the two-string property patterns, read-only record structs, mixing deconstruction. We covered a lot. Moved fast. Like I said, I'll make the code samples available for download. Any remaining questions I can answer before we adjourn?
Not a question, but just thanks very much. It was really amazing.
Thank you. Thank you for having me.
Yeah, I do have a question. So I love having choice, and it's great when you're not painted in a corner and you actually have options. But the thing with choices is now you have to choose.
Yep.
And So I'm just trying to think, because records are kind of like this in my mind. It's more of a limited use case class anyway. Like, at what point would I want a struct record versus a class record? Like, it almost feels like it kind of makes sense to always have my records as structs now. So what do I choose? How do I choose, Steve? Help me.
Yes, that's a very good point, and I probably should have talked about that a little bit more actually, because when you're thinking of, oh, I'm sorry, was someone talking? Oh, sorry, I must have heard something. That is true, and so a lot of times when we're talking about these concepts of, even when I go back to this, it has to do with when you're having this instance where if you have a type that you are building something in such a way that you're building a type that you really want to be a data holder, an immutable data holder, that is where you want it to be a struct. If you're building more of a domain object where, I'm going to be mutating the state and that kind of thing, that is more of a class. And maybe it's a large object that's going to hold lots of data. But if it's something that's truly a point, like the point class, where it has X and Y coordinates, is a date only, those little things where you're thinking it's going to really be probably less than 16 bytes on an instance size, that's where you're talking about having structs. Because just because it's, you can say, oh, well, these things are more efficient. That doesn't mean I should take a class that has, 30 properties and automatically make it a struct, because then you could actually put memory pressure on your stack as well. So classes are still the de facto choice in terms of, like, you have a business functionality where you're doing, typical data transfer objects and stuff like that. Structs are really when you're doing memory optimization and it truly represents a single value. Those are the instances where struct is really the appropriate choice. And in fact, Microsoft does have a whole sort of documentation page on this as well. They should probably advertise it a little bit more widely, but those are the things that you really want to use in your decision making, with that type of stuff.
Steve, with the struct keyword for records, for consistency, do you also have a class keyword that's redundant?
There's no class keyword because it's just understood that a record is a class by default, and it only is going to turn into a struct if you specify that keyword. And that's where I was showing you that in ILSpy to kind of prove that to you.
Thank you.
Steve, some of our we still have some projects that are stuck in the full framework days, and we've upgraded them all the way up to 4.8, which is the latest now for full framework. What language am I stuck with for my 4.8 projects?
Oh, good question. I have to check the documentation on that. I don't know. It is documented well, I will say that. So I'm not going to beat myself up for not knowing that one. But yeah, you're not going to be able to use C#10. I can tell you that. Okay, got it. Yeah, I wasn't sure. I know some like language features like kind of work as long as you have the latest version of the compiler, like IDE, and some language features have been like dependent upon the actual runtime that you're running. And that always confuses me because it's a mix, right? Sometimes like you'll have new features appear in our old version of the full framework projects, and we're like, wow, that's so cool. That new feature, it still works with our old cruddy projects, but it's not like consistent. It's I guess if it has runtime dependencies, it's not going to work. But we've been surprised in the past with having some features from the newer C# versions actually work where we didn't think it would work in full framework. Looks like you're up to get to use C# 7.3 here.
7.3. All right.
Yeah. And if you go net standard, then you might be a little bit further along with C# 8.
Oh, the 2.1 though, which we can't use 2.1, I don't think. I think we're limited to using 2 in full framework. Okay.
Yep. Then you're definitely down in this realm then. Yep.
Yeah. All right. Well, thank you for answering that.
All right. Well,
any more questions? Well, thank you very much, Steve, for coming here and sharing all of the awesome features in C#10. Now I need to go find a reason in our projects to use every one of these. I need to make up some needs and make sure I use them. Very cool, a little bit mind-blowing features. So really appreciate you coming here and sharing all of this with us today.
All right, thanks a lot.